Hey guys, welcome back to the channel. I have another interesting video, this time working on a MEFI 4. This is a marine engine computer. It's also used in RBs, not RBs, quadricycles, RTV vehicles, and so on, but this is for a boat. This is coming from Ireland, Northern Ireland. The customer name is Nigel Houston. He is from Dunboyne Avenue, County and Trim, Northern Ireland. So he said that please find and close a MEFI4 ECM which has the following issues. I launched my boat on a Friday evening after being dry the store all winter. It started on the first push of the button and was left running to get it up to temperature before taking it for a quick 10-minute run to make sure everything was working. Before returning to my it's probably morning in the marina and docking the boat. Went back to the boat on Sunday morning, and when trying to start it, it just kept turning over without firing. After some investigating, I discovered that the fuel pump wasn't being activated when turning on the ignition. Starting with the basics, I inspected the fuel pump relay, fuses, and lanyard safety switch to ensure they were not at fault. I then switched out the fuel pump relay of the ignition relay. Sorry, I then switch out the fuel pump relay for the ignition relay. Yeah, so he swapped it, no change. Verify that there was power to the fuel pump relay. Verify that the fuel pump was working by using a jumper wire in the relay. Confirm good. Verify the fuel pressure was good when fuel pump was on. Also good. Attempt to start the boat with the fuel pump relay removed and then a jumper cable installed manually turning the fuel pump on. Again, still no lock. Verified we have a spark. Test was good. All this led us to believe that the problem might be with the ECM, so we attempted to connect it with Diacom, which is the same software we use here from Rinda software, and the PCA did not recognize anything was connected. Trying this numerous times without any luck, confirmed our suspicious there was a problem with the ECM. And it's the engine details. It just says 2004-5 PCM CR6 6.0 liters. The rest is not really important, but yeah. So I was able to definitely reproduce his concern. I have the uh, screen capture running. So what I'm going to do is to start by bringing Rinda. As you can see, this is the same marine. The computer is on right now. I have, yeah, I can actually connect this to the fiber reference, which I have here. Let me just look for that. Yeah, so you can see that we have the fiber reference. So hopefully this can be looking to the video good. Let me just make sure it's still on the capture. Oh yeah, you guys are seeing that perfectly. So yeah, the computer is alive and it has fiber reference, but it's no communication. So I'm going to, now I have connected it to the, I was connected to the software here. So if I try to connect to Rinda, it just will soon be put in down here, no reply, and it's not detecting right now, not detecting the module. The computer does not run, so I got nothing going on. As you can see, no communication. So as you can see, I remove the cover from the computer because there is some things we can repair on these computers, some things not. I am an expert on these computers, pretty much in all the marine side ECMs. I am your guide to go if you have any problems with this. If I give you a report, a diagnostic report that is not repairable, is because it definitely cannot be repaired. Not just because I couldn't find the problem and then I'm just telling you to waste $4,000 or trying to find another computer. That's not the way that I do. For those that follow my channel, you will know that I take my time to investigate, to find the information and then repair. This is a hybrid ceramic board. So yeah, there is a lot of components that can be replaced in here, including the EPROM, and that was my hopes that this was the EPROM and not the microprocessor, which is actually at the end what is wrong with this computer. So I'm going to go a little back on what I have here. So I'm going to share some of the, this is years and years of information. This is the same computer here. that I had to take the time to map it out. I got a curve tracer, so I got all the signals to test injector drivers. I got the values that these computers should read based like in here. So I'm going to now and start to be watching this. I'm going to put the camera on the microscope so you guys can see what I'm seeing. So I'm going to switch to that. So I'm going to move the microscope around. Let me make sure it is in perfect. That is in focus. So I'm going to put an image you guys will not be able to see. So if you want to see the image that is I'm now on this on my screen, because you will be seeing just the camera, I'm going to need that to supply so see maybe a little bit in there you might be able to see. But yeah, I got all those voltages that this is a 5-volt regulator should be reading. So I'm going to just say the voltage that I'm about to test, and you will see me touching. So right here, this it should be reading 12.4. And if you see right there, it reads 12.4. I have a 5 volts in here, and we got the 5 volts. Which you have right here, 12 point something. Let me just make sure that I'm not jumping or shorting anything out. Well, even though the computer is not really good, but yeah, you see we got 12.5, and then on here we should have 5.3. Let me just, it's a little hard because it has a glue around it. But you can see 5.2, so it is good. And believe me, I check every single voltage on the entire computer, and it's there. So the next test that I wanted to do is then go over to the EPROM. So for the EPROM, which is right here, let me again slowly so you guys don't get too dizzy by looking into that. As you can see, I have removed that gel which I have in stock, so I don't mind removing gel if I have to then put it later. But so we can see there that we have a 95640 EPROM. So I'm going to go back to the display capture so you guys can see that information. So I got the EPROM in here. Oops, too much. Okay, so this is the EPROM. Let me actually zoom in a little bit. Maybe put the view into one page only. I was trying to put 2 pages, but that's not really working. One second. Single page view. Okay, so we got the pins. We got the clock. We got actually to know what it is each one. So we got the serial clock is C, the chip select is S, the serial data input is D, and the serial data output is Q. Obviously, we need to check, make sure we got the voltage supply, and then we got the ground. So this is what you need to do when you're checking an EPROM into any component. Um, Inputs to the EPROM, in order to work, you need to have the clock, the serial clock, and the chip select. You can go into more of the detail how the clock and all that stuff should look. This data sheet should have it, and we have it here. So if we see, so C is what it says, not this one. Let me go and see if it's anything more. Okay, this is, let me see, serial data. Trying to, okay, right here. So we got that the clock is active when the chip select is low. If the chip select is up, it can be either one. I mean, I'm just reading as in the order that we have it here, but we can see when the clock is high and chip select is high, there's no communication. But as soon as the chip select goes down, this is again coming from the microprocessor in order for the EPROM to be written and write. So when this goes down, there is a delay, and you can see engage, and then the clock starts sending information. Okay, I'm up, so start reading the information or writing the information on Q and D. So this is again the data input is D and the data output is Q. So this is what we should be, or what I was looking for to see on the EPROM. Do we have a better EPROM? If we have chip select and we have the clock, then the EPROM is bad, and then I can remove the EPROM, get a a EPROM reader, and try to transfer the data because these MEFI, some of them are uh, password lock and you cannot read it, but usually the password is through the microprocessor and not the EPROM. These are old style EPROMs. But yeah, so what I want you to see too is then I went over to let me actually go over to the pins before I put you in the camera, and then you can see the response um, on the oscilloscope, which I have right now. Hopefully everything is reading good. I was just reading some of the other signals that I will show you in a second. So I'm going to go here, and now I'm touching pin 1, which in this, oh, that's my multimeter, so we don't want to do that. For this, I'm using the Picoscope 6460. Let me see what the model is. One 6402D. This is a very capable. This is up to 2 gigahertz in one channel. So it's a very fast, when you're reading EPROMs, when you're reading clocks or crystals into the signals from the microprocessor or SPI communication, make sure that you're using an attenuated probe, not the one-on-one, because otherwise, I mean, it will just restart the computer, but you don't want to use that, and that's it, right? So I'm using one channel, so I got a lot of speed. As you can see, guys, in the setup of my scope, I got 1 microsecond per division. So I'm going to go over to pin 1, which is the let me just put it in here. 1 second. All right, so we are in S, which if we go back, S is the chip select. So this should be either high or low, but in this case, we got in chip select 5 volt reference. I mean 5 volts, not 5 volt reference, 5 volt. So let's go over to pin 6, which is clock, right? So C is the serial clock. That should be communicating, but I know there is not. So 1, 2, 3, 4, 5, and 6 on the other side of the EPROM, and I've got nothing. This is in 0, so it's low. And obviously Q pin 2 cannot be doing anything because if it's not chip select or clock active, then that is coming from the microprocessor. The microprocessor is dead. So we can also check in here. I can go over to pin, let me see, pin 4 and pin 8. Pin 4 is ground and pin 8 is voltage supply. So let's go over to pin 8 just to make sure that that EPROM has what is necessary for also for working. And we do have 5 volts right here. All right, if we go over to pin 4, we got a perfect ground. So this has everything for the EPROM to work, but it's nothing coming from the microprocessor. So let me take you over to again to the view on the camera for the microscope, so you can see what I'm doing in here. And now that you guys are seeing that, I'm going to move this over here, put this over this side, so you are the ones that are looking at the camera, not me. All right, so we're gonna do the same test, and you guys will be seeing that I'm indeed touching those pins. So let's go over to S, which is pin 1, just to make sure that I'm saying that correct. Yes, S is pin 1, which is the chip select. So again, looking at the design, it has a bevel side. This is pin 1 on all the EPROMs, and we can see that we have 5 volts in there. So that is what I'm saying. So no communication. If I go over to pin C, which is the 6, right? Yeah. Pin C, which is the number of the 6th pin. So 1, 2, 3, 4, 5, and 6, right? And now, sorry, I'm in the way, but you can see that I'm now on pin 6. And if I see over there, it's just low. So the clock is dead. And then the other pins we already checked. So things that I was also looking for, because sometimes a microprocessor, it can become dead if you have a bad crystal. So let me bring this information down. I'm going to keep you in the screen I am very familiar with this computer. So this is a ceramic crystal, and I think this is, let me see if I can read that. I think it's a 4, yeah, it's a 4 megahertz. So if we touch in here, we should have 4 megahertz. So we're going to, I'm just going to touch on, this is a crystal right here. So I'm in one side and then touch in the other side to make sure voltages change a little bit, but not much. So I'm going to switch, sorry if we keep switching this, but now I'm going to put in display capture so we can see the oscilloscope complete. And then again, this is a 4 megahertz. So I'm going to stop the capture and then now put some rulers. So if you want to know what the frequency of that resonator is, we can see it's 3.979, so it's perfect. And then the amplitude is also really important. So you want to make sure that when you're reading that, I got, known goods. Again, I've been doing this for a very long time. So we know, I know that I got, 5.4, so this is the correct amplitude for this one. So we had this one is for one I see here, which is also in control of some of the um, task of the computer. But the main one coming for the microprocessor is this one here. You're not going to be able to see this, but this has also the markings where I can see that it says that it is also a 4 megabyte, sorry, 4 megahertz. So we're going to read that one. Okay, I'm going to get all this out of the way and then touch and again use an attenuated probe when you're doing this. And you'll see that this signal is a lot smaller. Again, this is the way it should be. Let's stop the capture so I can release my hand and then we can check the speed. So we go from low and to the low in the next one. So one cycle, right? So you can take the upper one and then the upper one or the lower one and the lower one. But you can see it's 3.979 megahertz. So that's perfect. And we can measure the amplitude in here too. And you can see that obviously immediately that this is smaller than the one before. But again, with my experience, I know 3.3 volts is exactly what we are supposed to have in this one and almost 5 volts, a little over 5 volts on the other side. Again, I check everything else is good. This microprocessor has everything in order to work. I can also check if I want to because let's say the microprocessor on this computer is here. I'm sorry to give. Now, it's actually very important and very nice that I can share all this information with you. So let me go back to this screen capture software. Um, I want to put them in there. And let me go into the microscope. All right, so now you guys can see perfectly good in there. So I'm going to move this microscope and not the. So you will be able to see what I'm checking. So again, with all my information that I have from years and years of doing this, let me see what is that information. You'll see that I have. I mean, yeah. So you can see just customers report from years and years and years and years of working on this. I have probably repaired maybe 10,000 computers. So you're in good hands if you send the stuff to me. I know what I'm doing, and if I don't, I will get the information, find out, and check it the correct way, or not return, or I will return it to you with no cost. All right, so but yeah, so if I go here, I can see the voltage rails around the microprocessor, 5 volts and 3.3, and this center one is ground. So we are now going to the, yes, you guys are looking in there. So the outside one should be reading 5 volts, and the center one, sorry, the inside one is 3.3. So I'm going to touch that. And as you can see, we got the 5 volts in there. If I touch the center one, we got the 3.3. And obviously, check also your ground, and it's 0.019. So that's a perfect ground. Um, this is one thing that you will notice when you have an open circuit into your multimeter. is like that. It's bouncing up and down because it's not a reference voltage going through, and I cannot read the voltage difference or resistance, right? So that's as much as I want to share in here. This is it. I mean, I'm going to call this customer and I go, I'm sorry, but your computer is deemed not repairable. We have a problem with the microprocessor. I hope that you see that I take my time to do a full 100% test when I give you a report for your computer. Again, guys, thank you so much for visiting the channel. Don't forget to subscribe. I always like to share information and share tests. This you can apply to a lot of computers around. I will be shortly starting a paid channel or a paid website to promote classes on how to become a diagnostician on European vehicles and how to repair engine computers pretty much across the board. I cannot say just marine or automotive. I mean, this applies to a lot of devices across the board. So, all right. All right. No, I will not take more of your time. I'll see you next time. Don't forget to subscribe. Thank you so much. Bye bye.